All right, so today we are actually reviewing lessons 1 through 4 so that you'll be able to do well on a quiz. Um, so here's a warm up for today. So Louisville's Jack-O-Lantern Spectacular, let's try that again. Louisville's Jack-O-Lantern Spectacular is a drive-through experience. So they charge you by the carload of people. Now, I don't know if any of you've been to the Jack-O-Lantern Spectacular, but in Iroquois Park, they have a bunch of carved pumpkins. I think it's like over 5,000 pumpkins that you can actually now drive through, used to be able to walk through, to look at all of them. So it's kind of a fun fall experience. And so now we know we're going to look at Damo. And Damo has a big family. And he and all of his extended family, his aunts, his uncles, his, cousins, nephews, nieces, they all went to the spectacular and they actually filled up 4 cars. All right. Now, like we said up here, they charge you by the carload. And Damo was really nice and he paid for all 4 cars for his family and ended up spending $140. So now you have to answer this question here. How much did it cost per car to go through the spectacular? All right. This is actually, I don't know why it's doing this, but anyway. All right. So we have to figure this out. And notice here it says answer the question and then make a table that shows the information. I'm actually going to do the opposite. I'm going to make my table first. Okay. So we know the information here is that we know how many cars went, right? So I'm going to say cars. And we also know how much they cost. So I'm going to do a table. Okay. And we know Damo had 4 cars in his family and it cost $140. That's a lot of money. So we now have to figure out, well, how do we get from 4 cars to $140, right? Because we want to know, what does 1 car cost? That's what they asked us, right? How much does it cost for 1 car to go through? So, gosh, let's think about this for a second. I like to, if I don't understand how to do these problems, I like to use a bar model. And in my bar model, I know we have 4 cars. You could actually draw cars if you wanted. I just happen to use bar models because I'm not a very good artist. So I'm going to draw a bar and I'm going to make 4 different pieces in my bar. 1, 2, 3, 4. You may have called these tape diagrams in 6th grade. And so I have 4 cars and I know that all 4 together cost $140. And really I need to know, what did just 1 car cost, right? So in order to do that, I'm going to have to look at this and I'm going to have to take 140 and I'm going to divide it, right? It's being divided into 4 equal pieces. So I'm going to take 140 and I'm going to divide it by 4. And that should tell me what 1 car costs, right? So I know, let's see here, let's do 140 divided by 4. You could use a calculator. I am too lazy to even pull that up. That's how lazy I am, right? Okay, so I know 4 goes into 14 3 times because 4 times 3 is 12. And I know that gives me 2 left over. And then I drop that down. Oh, okay, cool. This is going to work out evenly. So then 4 goes into 25 times, and there's no leftovers here. That works out evenly. So I actually know this is going to be $35 in each box, right? So okay, so I'm going to say over here, I'll put this back on my arrow. So we know this is going to be $35 based on what we just found here, right? Okay, and that's good because, well, let's kind of double check. Is that even an answer? Oh, yeah, it is. So $35. Cool. That was our warm up. This is stuff that we've already done, right? Now, let's look at our objectives. Our objectives are actually the same as they were for the last class, and that's we can fill a table. If it's a proportional relationship, we can find the COP for a proportional relationship, meaning constant or proportionality, and we can also write an equation for a proportional relationship. So let's take a look. We're doing more with the spectacular. So Odysseus carved pumpkins for this year's jack-o'-lantern spectacular, and it took him 120 minutes to carve 3 pumpkins. It says fill in the table below using that information. Okay, so as I'm looking, they've already entered that it took 120 minutes to carve 3 pumpkins. So now, gosh, again, we're trying to figure this out. There's a couple ways we can do it. We can look at this. I like to find what we call the unit rate. And so I know this is kind of like what we did last time. I know this time we can do this in a couple ways, right? So I know 3 pumpkins. This is going to be 3 pumpkins. And I know these 3 take 120 minutes, right? And really what I'm trying to figure out here is how are these related, right? So if it takes 120 minutes for 3, could we figure out what 1 pumpkin is worth in time, right? So again, all right, for this, let's see, 120 and it's being divided into 3. So that's going to be 40 because 3 times 40 is 120. Okay. All right. So interesting. So I think we just answered the next question because look, it says if you have 40 minutes, how many pumpkins can you do in 40 minutes? Well, we just figured that out, right? So I kind of figured out too, like to get from the pumpkins to minutes, we do times 40, sorry, not times 3, right? So this is 1 because 1 times 40 is 40. I can also look at it this way and go, okay, well, 120 divided by 40 is actually the equation, or that's how I can get from minutes to pumpkins, right? We do 120. If I divide it by 40, I get 3. 40 divided by 40 will give me 1, right? There's lots of different ways you can fill in these tables, really, okay? Now, this is saying if I had 10 pumpkins, how long does it take? So I know, well, let's see, 3 pumpkins is 40, right? So I could keep drawing 40, adding pumpkins on here, right? 40 minutes at a time, right? And so I know if I had 10 pumpkins, each one is going to take 40 minutes. So I'm going to multiply 10 times 40, and that is going to give me 400. So it takes 400 minutes to do 10 pumpkins. All right. So you can see you can use division or multiplication to solve it, to solve missing pieces of tables. All right. So let's see what's next. So now we're looking at some tables, and it says y equals kx. All right, cool. I remember this from last lesson. It says y equals kx is like a recipe, and it tells you how to write an equation for a table. So, and I'm going to use this space here for right now. So y equals kx is a recipe. That means it's kind of like the directions on how to find a proportional relationship. So the y is always going to be whatever is in the second column. The x from here is always what's in this first column. And the k is always the COP, or the constant or proportionality of the table. Okay, so let's kind of look at and see what that means. So we have these tables, and we need to find the COP for this table, right? Constant proportionality is always what am I multiplying x by to get y, right? Multiply, not divide, multiply. So I know 7 to get to 56 is times 8. Okay, and I know 3 times 8 is also 24, which is awesome because it's matching up. So I know because I have to do, no matter what x is over here, I have to multiply it by 8. So that means my COP is 8. All right. Now, it says find the COP and write an equation. So if I want to write an equation for this table, I'm going to follow this formula y equals kx. And this is a little bit easy for these because our tables are actually labeled x and y. So I know y, like in this case, 56, watch, 56 is my y, and it is equal to k, and k is the COP. 56 is equal to 8 times x, and in this case, x was 7. Does that check out? 56 is equal to 8 times 7, and 8 times 7 is 56. So that is right. That works out, right? Same thing for this. 24 is equal, because that's 24 is in the y, it's equal to the COP, which is 8 times x, and x is 3. And is 24 equal to 8 times 3? Yes, it is. So this is working out. So the equation that we follow for this table is simple. We're going to take our y, whatever y is equal to the COP, which is 8 times x. So the equation for this table, y equals 8x. I'm going to erase this for now. And actually, I'm going to write that in here because it does say find the COP and then write the equation. So the equation is, next to here is y equals 8x. Okay. Now, let's look at this table. We have to do the same thing. We're going to find the COP and we're going to write an equation for it. So again, let's figure out the COP, right? The COP is, and a lot of people look at this and they'll go, oh, okay, cool. 45 divided by 9 is 5. So we divide by 9. 36 to 4. Oh, we divide by 9 again. 90 divided by 9 is also 10. So we get the same thing. And so a lot of people say, oh, the COP, 9. And that's not right. It's close, but it's not quite right. So remember, the COP is what we multiply x by to get y, not what we divide by, right? So the COP, now some people might go, oh gosh, I don't know. I don't know that fact. 45 times what is 5? Well, there's actually an easy way to do this. Because when you divide by a number, it's actually the same thing as multiplying by its reciprocal. So remember, reciprocal simply means when you have a fraction and you flip the numerator and denominator. So some people might go, well, 9's not a fraction. That's true. But if we look at the number 9, we can write it as a fraction. And 9 as a fraction is 9 over 1. Okay, this is stuff that we learned in 4th and 5th grade. Okay, so if 9 over 1 is the fraction for 9, that means multiplying by 1/9, its reciprocal is the same as dividing by 9. All right, and we can do that. That means for all of these, instead of dividing by 9, we're going to multiply by 1/9. And since we're multiplying all these by 1/9, that's our COP. So our COP is, I'm going to write that in, 1/9. Oh, I have to type it in. That's all right. So this is 1/9. All right, now we have to write an equation. And remember, the equation is trying to figure, it's a recipe. It's telling us, how are we getting this answer over here, this y? What are we doing to get that? So when we go over here, the recipe is for proportional relationships. It's always going to look like y equals the constant times x. Okay? So in this case, what did we do to get y? Well, y was equal to and the constant, the k, is the COP, right? Because we're always multiplying by the 1/9. We take the 1/9 and we multiply it by whatever x is. So here x is 45. We multiplied it by 1/9. This is 90 is x. To get the y, we multiply by 1/9. So we always take 1/9 and we multiply it by x. And so our equation is y equals 1/9 times x, or 1/9 x. Okay? Now we're going to apply this recipe to the next one. All right? So now we've got that same chart that we had before, the same table that we found out. We knew that Odysseus was carving pumpkins and he did 120 minutes. He got 3 pumpkins done. And let's remind ourselves here, what was the COP for this? The constant of proportionality, because if we know the constant of proportionality, we can easily follow this recipe because the recipe shows us how to make an equation for these, okay? So if the minutes, oops, I can't put that in there. Oh, and that should be in the directions. If minutes is X and the number of pumpkins is Y, okay, then we know in order to get the number of pumpkins, we're going to do Y, the number of pumpkins, is equal to whatever the constant of proportionality was for this table times X. And so for this, so this is X and this is Y. So now we got to think to ourselves, all right, constant of proportionality, how do we get from X to Y? Well, we divided by 40 on all of these, right? But if you remember from before, we cannot, that does not mean 40 is our constant of proportionality, because constant of proportionality is what we multiply by, all right? So again, we're using our little trick. Dividing by 40 is actually the same thing as multiplying by 1/40, right? So our COP is actually 1/40 because that's what we multiply X by to get Y. And that tells us our equation is going to be the number of pumpkins, or Y, is equal to our constant of proportionality, which is 1/40. Sorry, guys, I live by the airport, so you can probably hear those planes going by. So it's the constant of proportionality times X. And this is our equation. So now let's double check. Can we fill in a table for a proportional relationship? Yes, you can use multiplying or dividing to do that. Can we find the COP for a proportional relationship? Yes, we can. Remember, COP is the number we multiply our X, or our first number, by to get to the second number. And finally, can we write an equation for a proportional relationship? Yes. Y is equal to K times X, or Y is equal to the constant of proportionality times X.